Next example here, I've got, we're asked to integrate from 0 to pi over 2, the square root of 1 minus cosine theta d theta. This one, we're going to use some trig identities, and in particular, we're going to use the fact that sine squared theta is equal to 1 minus cosine 2 theta over 2. So 2 sine squared theta is equal to 1 minus cosine 2 theta. Now, hopefully you can see that the 1 minus cosine 2 theta is very similar to what we have here. I just don't have the 2, I just have a theta, but that's no problem. If I change this 2 theta to just a theta, then over here on the left it becomes a theta over 2. So 2 sine squared of theta over 2 is equal to 1 minus cosine of theta. So I'm going to go ahead and use this substitution. So again, we're integrating from 0 to pi over 2. And we've got the square root now of 2 times sine squared theta over 2, d theta. The square root of 2 is just the square root of 2. I can't do anything about that. But the square root of sine squared is just going to be sine of theta over 2. The square root of 2, I'm going to bring that in front of the integral. And then inside it, I've got sine of theta over 2 d theta. Now I'm just about ready to integrate here. Since I've got sine of theta over 2, I'm going to need to have the derivative of theta over 2 inside of this integral. The derivative of theta over 2 would just be 1/2 d theta. So I need a 1/2 inside, and I can go ahead and do that. Let's just multiply by 1/2. And to accommodate that, I'll multiply in front here by a 2. Okay? Because remember the chain rule. So it's we've got to have that sine of theta over 2, again, times that derivative. So now we can go ahead and integrate. Got 2 times the square root of 2 in front. When you integrate sine of something, you're going to get negative cosine of that thing. So in this case, negative cosine of theta over 2. And we're going to evaluate that from 0 to pi over 2. So we have negative cosine of pi over 2 over 2, so that'd be pi over 4. Then minus the negative cosine, so plus the cosine of 0 over 2, which is cosine of 0. The cosine of pi over 4 is 1 over the square root of 2, and cosine of 0 is 1. If I go ahead and take that square root of 2 and distribute it here, I end up with 2 times negative 1 plus the square root of 2. And if you don't like to lead off with a negative, you could rewrite this as 2 times the square root of 2 plus 1, or sorry, not plus 1, minus 1. Or you could just distribute the whole thing and write 2 times the square root of 2 minus 2. All of them are perfectly valid answers.